record. I got it. And then share screen. This one. Okay, move these over here. How many people? 1, 2, 3, 4, 5, 6, 7, 8, 9. I guess that's enough people. Hi, Justice. um, okay, so I also think when you share your screen, it gets, oh God, it gets tiny, so. Okay, so can everyone, oh my God. Okay, can everyone see this clear enough? Is it too small? Thumbs up. Okay, cool. So this is what it's going to look like when you guys, if you haven't already, just go into the Brightspace page and download your data. I'm going to say, I'm going to label this raw data. Right, so the first step you want to do is literally copy and paste the template you have there and delete it. What are you doing? You want to say hi?
No.
Okay, so delete it, right? Label this corrected data, parentheses, data minus blank. And I'm going to capitalize blank because it's not placeholder, it's a thing. Whatever. Okay, and then, so I'm going to cheat a little bit because I have this already done. Oh, look, all this stuff. Right one. So you're going to want to build a table. Your lab protocol has like instructions and instructions how to do this and what information to include. So you're going to want to build a column for your samples, right? Blank, standard, 1, 2, 3, 4, 5. Your samples. So let's do, this is kind of how I recommended everyone do it. Right, so control, df10, df20, spell things right, control. Right, and I'm just going to stop here with drug 1. But hopefully you get the idea, right? So drug 1, df1, drug 1, df10, drug 1, df20, etc. Nope, not yellow. No fill. No fill. And then, so we want to add in the concentration of our standards, right? So we're starting to build our table here. Standard 1 was 0.125. And as like a FYI, I guess, if you guys don't remember directly from Gen Chem, that's the closest thing I can think of that's done like this. If you label a column something, like here it's concentration, and you put units there, you don't have to add units the whole column down. It's Excel won't like it. It won't do math very well for you if you do that. But B, it would be redundant. So 0.5, 1, and 2, right? So we know standard 1 was 0.125 mg per mil. All the way up to standard 5 is 2 mg per mil. Any questions so far? Okay, so we need a concentration column. We need an average absorbance. Uh-oh, someone wants in. My bad. Sorry, Salma, I didn't see the thing popping up on my screen. So, do you have any questions, Salma? We're only up to, like, we're starting to build this table, and I'm just talking about what's in it. Are people talking and my phone's just not? No. Okay. All right. So, yep. Your sample column, concentration column. The way the instructions have this set up, and typically what you would do anyway, is put an average A562 uncorrected. So this is the average absorbance at wavelength 562. Uncorrected with all values. And then we have our corrected average A562 absorbance with all values. And then this next column is our average absorbance without any outliers. In this data set, what are you doing? Stop it. Stop. This data set looks like it has some outliers, so that will basically work out for us. Then standard deviation, CV coefficient of variance, which I have to triple check. Where's this? Triple check my math on that. Yep. So where are we for that? Step 14 basically lays out what you need for your table. I'm just double checking. Yeah, standard deviation divided by average times 100. Okay. And then concentration, I have this extra one here. This is basically the concentration of whatever sample using the formula we're going to derive from our linearized curve. Okay. Everyone good so far? No questions? Okay, so the first thing we want to do is get the average value of our blank signal, right? So if we go to blank, average uncorrected with all values, we can type in equal. Here, let me delete. So can everyone see this, right? If you type in equals average, it's a formula. So you either pick it from the drop-down menu or you can type the whole thing, parentheses, and then you're going to want to go up here and select the cells that contained your three blank signals, right? So this is our absorbance for our triplicate blank readings. Close the parentheses, hit enter. Good so far? Is that a thumbs up, Katie? Okay, so now we have our, I'm going to shrink this because it has too many numbers. So now we have our average absorbance of our plate as well as our BCA solution, right? The only thing in these wells should have been the plastic from the plate and then the BCA reagent. So this is how much background absorbance those produce. So to correct for those values, we're going to go up here to A1, type in equals, and then click on the corresponding A1 from your raw data. Yeah, okay. Click on it, push minus, and then go back down to our table here where we have our averaged absorbance uncorrected, and click on that cell. So you click on that cell, and then it, whatever the cell ID here, whatever the cell ID is here, it's E32. Jump in front of the E, put a $sign, and then move over, jump in front of the number, put another $sign. So what putting this $sign here does is lock in. It basically tells Excel, do not move this cell ID for anything. It's going to lock it in so it doesn't move. And press return. Okay, so now we have 0.066 minus this average value down here, 0.065. So the answer is 0.01. So that is the corrected value for that single well. Any questions? Okay, now the fun part about Excel is because we put those dollar symbols in here and this template matches this template basically with the way I lined them up and everything, we can grab the bottom right-hand corner of this cell and drag it over here to 12. And it's going to do the same thing for all those cells, right? So basically what I did was copy the formula over. So now if I click on what would be A2, it's moved the cell ID over. So now we have 0.065 minus 0.065, again, because I locked E32 in place. And it basically, if you look up here, I don't know how well you can see it, it basically does that for every single cell automatically, right? And then the next step, highlight that whole row and drag it down to D. Bam. Now you have all your corrected values done. And I'm deleting these because there's nothing there. Okay. Any questions with that? Pretty straightforward. Okay. So now we have our corrected data, our corrected values. Now we're going to build our standard curve. So we're going to start this by plugging in, well, I'm not going to bother filling this column in, but we're going to do this by filling in our column for the average A562 corrected values. And actually, before I do that, I'm going to do this. So up here in red, I have outliers. I mark them with yellow. And so because I know these are outliers, I'm just going to delete them. Right? If they're outliers, we don't need them in our corrected data set. All they're going to do is complicate things. So I've clicked on our blank average value here, right? We're just averaging these boxes up here. I click on it, copy it, paste. And so I pasted it into the average A562 corrected, and I'm just going to drag that down. So what this is, I won't drag it down yet, right? So I copy and pasted that value from here to here, one cell to the right. So if I double click this now, what Excel has done is been like, okay, so you want to average this 3 cells just to the right of the first 3 cells, right? So that's what we did. That's what we avoided when I added those dollar symbols in the math before. The dollar symbols stop Excel from moving things 1 or 2 cells or 5 cells up, down, left, right, whatever. It locks it in place. So I'm going to actually fix this first. So double click. You can basically grab that 3-box thing, right? The 3 boxes it's averaging. Because this is in the blank row, I'm moving it to where the corrected blank values are, right? And so that should equal 0 if everything's done correctly. Now I'm going to cheat a little bit and just grab the bottom right of that cell again, drag it down to standard 5 and let go. So you'll notice these are like all over the place and all sorts of wrong. What's up with that?
Can you say that again? That was like low-key confusing.
Yeah, which the drag on the right.
Like when you like grabbed the 3 and then like brought it down or whatever.
How did you get the 0?
Yeah.
This thing right here.
Yeah.
So now, here I'll delete. Right. So if I copy, if we look here in this file, in this cell, it's averaging these 3 wells. Does that make sense? So if I copy, paste, what I've done now is basically I told Excel, okay, take the, it copies the information in the cell and says, okay, now take the average of this. I've moved it over once. So basically Excel's like, okay, you want the average of the 3 cells directly to the right.
Okay.
But, that's not what we want. So you can grab those 3 and just drag it down over here to A1, 2, and 3 from the corrected values.
Okay, I got it now. Thanks.
Okay. Yep. And then return. So we're going to do this again, grab the bottom right. And so Excel basically just did the same thing as before. So we copy and pasted that cell ID information down 1. So what it's literally done is been like, oh, okay, well, you want to grab the average of the 3 cells, 1 below where they were before, which isn't what we want, right? Because standard 1 is over here in A4, A5, and A6. So just go ahead and grab it, move it over, hit return. And then if we keep following that pattern, right, this cell is 2 below where the original formula was. So it's like, oh, well, you want the average 2 below, but we don't. So grab it, drag it over, put it on standard 2, the corrected absorbance values for standard 2. Standard 3, standard 4. Looks like we're going to delete standard 4 because it looks wrong. And come on, standard 5. Okay. So far, so good. I'm just going to do this without outliers because I've removed them. Okay, is everyone good still? Okay, so now hopefully everyone recognizes this as basically what I drew on the board, right? I drew the linear curve that maps our known concentrations back to our observed absorbances. So now we'll see if it's going to work like this. I might have to change it, right? So I'm selecting my X values over here, right? So these are going to be on our X axis and then our Y axis values over here. If you go up to insert, Excel is going to give you basically a bunch of different options for graphs. You want to go to XY scatter and then click the one with just the dots. Yep, perfect. So it didn't, it's saying so, yeah. Okay, so series 2, right? We have our dots that correspond to these values over here, right? So X value of 0.125, Y value of 0.035, right? So here's our series 2 point, 0.125, X, and Y is 0.035. Look good? Okay, and so I think I'm like vaguely remembering everybody's plates. I think everyone's standards were fine, so you guys probably won't have to do this. But if you do, if you have a standard that's like nowhere near the appropriate linear pattern here, like this, like our standard for this raw data is from, I don't know, a year ago. They probably didn't pipette in their standard 4. So if something like this happens, all we're going to do is go in and delete it. So now that data point's gone, and now we can have Excel do a more accurate linear curve. Everyone still with me so far? Okay, so now we've done that. If we click on our little data thing here, we go up to chart design, add chart element. We go down to trend line and pick linear. And so I have 2 series here, series 2. Wah. There we go. There's our line there's a linear line. Does anyone know what's missing here? Nobody knows what's missing? We're missing our y equals mx plus b, right? So go ahead and click on the line, clicked on it. Now this is the fun part. I don't know if I right click. Yep. So right click, format trend line. It's going to open this obnoxious thing over here. We want to click on display equation on chart and display R squared value on chart. So that will give us our y equals mx plus b formula, which I want to be bigger. And it also gives us our R squared value. Does anyone remember what the R squared value means? So the closer your R squared value is to 1, the closer your linear equation here matches up with your data, right? So closer to 1 is better. Okay, so there's that. Next, let's add in, so I'll just comment this here. When you make your standard curve, do not include your blank, right? You shouldn't have a data point down here at 0, 0. You don't want to include your blank. So the next thing we got to add to our standardized curve is the standard deviation for each of those measurements. So if we go to standard 1, over here, standard deviation, type in equals, and then type standard. Where'd it go? Okay, I lied. Type equals STDEV. Right, and then I'm fine with you guys using just STDEV. You don't have to use like population or series or anything like that. So STDEV, and then we want to take the standard deviation of the corrected values from our data above. So in this case, standard 1, right, maps back to A4, A5, A6. Enter. And then same as we did with the averages, just drag that down and then correct for where they went, right? So this is standard 2, standard 3. I'm leaving standard 4 out because it's screwed up, and standard 5. So now we have standard deviation for those data points. So good? You have a question, Sarah? I cannot hear you.
Like me?
Oh, yep. Do you have a question?
No, I was just confused, but I'm good. Thank you.
Anything I can say to help clear up the confusion?
No, I just couldn't look at the numbers, but now I can. Like now I'm good.
Okay. Cool. So now we want to click on one of our dots. I'm going to try right clicking. I might have to add a. No. Okay, so I'm going to click on our dots. I'm going to go back up to chart design. Add chart element. Yeah. Add chart element, error bars, more error bar options. And we want to enter custom error bars. That's, yeah, right. So custom, specify value, pick your, basically you just highlight your thing here, the cells you just calculated your standard error in, or your standard deviation, and boom. No. Oh, that's fine. Right? Yeah, you can just click. So we only want Y error bars up and down. We don't want that X error bars. So if it adds X, get rid of it. So we also want to add.
How do you get rid of the X?
The X error bars.
Yes.
Just click on only the X error bars and just hit delete or backspace. Okay, and then so we also want to add, I'm just going to show you how to do this. I'm not going to do it for you, but we want access titles. Here we are. So access titles, right over here is either optical density 562 or ABS 562. Right, so OD stands for optical density. ABS is just absorbance. And you can use either one. But the point is that you need to tell us what wavelength, what wavelength of light we did our measurements at, right? And then also, chart design, add chart element, axis title. Make sure you are labeling your x-axis. So this is protein concentration, and make sure you put units on it, right? Mgs per mil. Not 9 per mil. Mgs per mil. And whatever you want for a chart title. Make sure it describes what you're doing. Okay, there's your standard curve. Ta-da! So last thing, for our CV, remember that is, I'm going to double check. It is standard deviation, right, which we've calculated right here, divided by average times 100. And drag down. So there's our CV percent for everything. Okay, so wow. Hopefully everyone remembers from class that this Y equals mx plus b formula links absorbance to concentration, right? But the way it's set up right now is that you need to know the concentration, right? You plug in concentration and you could calculate absorbance, the Y value. So we need to rearrange our Y equals mx plus b formula so that we can plug in absorbance to obtain concentration. So we just rearrange that, and I'll just type it, right? It's going to be Y minus B divided by M equals X. So I'm going to put the numbers from my chart right here so that they're like ready to go. So that would mean Y minus B, Y is our absorbance. How am I doing this? I think I can just type it in once. So actually, if you go over here to correction with the formula, equals our absorbance value minus B, which is 0.0148, divided by M, 0.3098. This isn't the best data set, obviously. Okay, so it's not awful. So so what I've just done now is basically use the formula we calculated and calculated, I guess, to see if I could back calculate the concentrations of our standards. So if you look here, it's saying standard 1, which we know has a concentration of 0.125, should be 0.065, which isn't very close, right? But that's that's basically the issue with any of this, right? So if you look at our linear curve fits essentially our 0.5 and our 2 much more closely than our low values over here. So like this is a little off, this is a little off, but it's pretty much spot on for standard 3 and standard 5. Right? So it's not perfect, it's never going to be perfect, but it's pretty darn close. Okay, any questions? All right, so we've done it for our standards. We have our standard curve. We have our standard curve formula. Here, it's just a lot of mouse work, basically. So we want to now take the average A562 corrected without outliers for everything else, right? Your control DF1, your control DF10, your control of DF20, drug 1, DF1, et cetera, et cetera, et cetera. But so you can grab this, drag it down to copy. But remember, we have to correct those things. So we know control DF1's over here. We know control DF10 is over here. Control DF20. Drug 1. Yep, DF1. Drug 2. DF2. I'm going to stop here at drug 2, DF20. Okay, so I mean, it's basically just the same process. I'm just not going to keep doing it. Okay, so we have our average A562 corrected values. Really. You also have to do your standard deviation. So same thing. If you drag and drop that, you just got to fix the stupid areas. Okay, right, standard deviations calculated. So because our CV formula here just references the two boxes to the left, we can copy and drag that down. And our y equal, or our rearranged, our y minus b divided by m equals x formula also just references this. So we can grab both of those, drag them down. Right. So hopefully everyone remembers, as we were going through everyone's data, I basically told you which dilution factors you could or couldn't use. Almost everybody's using their DF of 1s. So when you choose which dilution factor to use, I think I've mentioned this in every class, you need to pick a dilution factor with an average absorbance within the range of your standards, right? So here, control DF1, his absorbance is technically somewhere over here. So because we didn't test the absorbance versus concentration outside of this range, we don't know what the relationship is between absorbance and concentration. It may be some other formula might dictate it, right? We can't be sure our linear formula here dictates that. So, like I said, almost everybody's data was fine. Yeah, almost everybody's data was fine. But if it wasn't, right, our DF of 10 here with an absorbance of 0.128 does fall within our curves. So 0.128 falls in between standard 1 and standard 3, basically. So we can use that. So if we use our formula and our absorbance value here, we find out that our control DF10 has a concentration of 0.366. Does anyone know what the issue or what needs to be corrected now? So because this is a diluted sample, that means the concentration of the DF of 10 is 0.366. It literally means that, you know, a solution that is 1/10 the concentration of the original sample has a concentration of 0.366. So does anyone know how to correct for a dilution factor of 10? on pause. Come on. Does anyone want to guess to how you would fix, what is this? Fix a dilution factor of 10? So someone asked in the chat, is it okay if the y-axis title on the graph is called absorbance at 562 nanometers? Do we need the wavelength in the y-axis title? It doesn't hurt, right? So you can definitely put nanometers, right? Doesn't hurt. Okay, so the way you correct for dilution factors is we know it's a DF of 10, so we just multiply it by 10. So that would mean we've extrapolated that the concentration of undiluted sample control has a concentration of 3.66 milligrams per milliliter protein. And if it's a DF of 1, you don't have to do that because it's undiluted. Does anyone know what we would do with a DF of 20? Multiply it by 20. I saw that. Yeah. Right. And so if your formula is done right and your samples are consistent, these should be the same number. Right? Because they should all fit within if they all fit within the linear curve, the absorbance versus concentration should fit the linear curve. And so that's basically it. You'd have to do it for everything, but and that's what you need to show up with next week, right? You need to have your concentration of your control, concentration of your DF or of drug replicate 1, and concentration of drug replicate 2. And that's all there is to it.
Is this what's due tomorrow at midnight, or is it due in the beginning of lab?
Yeah, I mean, just make sure it's done before lab next week.
Okay, and then I also was wondering, we didn't have our values put in first, but we were like going through the motions. Will our graph correct, or will we have to redo our graph?
So if what is click? So if your graph,
no, it didn't.
Graph is set up to like pick up data like this, if it has these standing boxes, basically. I don't need this. Basically, anytime you change numbers, your graph will auto update. The trick with that, what just happened? Where'd my line?
Oh no. Just Command Z.
Yeah, I don't know what that was about. Yeah, so as long as it's highlighted like this, any changes you make here will change your graph. If you already have it set to calculate your linear curve too, that's also going to change anytime you change data over here. So just be aware of that. Okay, that's it. Anyone else have any other questions? Yep, go ahead, Sarah.
Will this be uploaded tonight to Brightspace?
Maybe it'll depend on how long it takes to download and then upload and everything else. The other 2 videos I have uploaded are basically the same process though.
Thank you.
Oh, whoops. I didn't see these chats earlier. Okay, yep, so that's that for now. What do I got for battery life? Some. So I'm just gonna leave this on. I'm gonna run upstairs and I'll be back. I think the 8 o'clock shift is gonna start soon. So stick around if you want, or head out if you want, I suppose. So I'll be back in roughly 12 minutes.
Thank you. Have a nice night.
You too. You guys aren't going to stick around for a second hour, are you?
No, we're confused.
Well,
Where did
Where'd you go?
you cannot find you?
I turned the thing off.
Oh, yeah. I mean, we just didn't have any of our numbers in, so everything's like blank. But
We'll figure it out.
yeah.
I think we'll be fine.
So do you still want it submitted tomorrow? I'm confused.
I mean, if it's done, submit it tomorrow. Yeah. Otherwise, you can just wait.
Okay.
It's so weird that he's like looking over there.
I'm using my phone is doing the zooming, and then my two monitors are
That is
are
us.
doing the rest of everything.
Well, no, it's because when you were counting people, I wanted you to know I was here too, and I counted. So then I got back in the camera. And we were the people who voted in, like, we're wanting 8 o'clock, so it might not be anyone, but our club got out early.
Okay, gotcha. I don't know if Tareem's still here. I don't think she is. No, I don't think she is. I'll have to email her.
Alright.
So you guys had the same question. Tareem asked, do we need to correct? I think she's saying, do we need to have concentration corrections, for the dilution factors? Or do we need to concentration correct for dilution factors for the standard? So I think what she's asking is, like, is there a concentration correction for the standards? The standards come as is, so there's no need to correct anything. They're set as they are.
And you said that if we had an outlier, because we had one that had an issue, just delete it off of our chart, our corrected chart.
Yeah, yep. Highlight it in yellow so that way when you upload or when you copy and paste the data into your notebook, I'll know that it's an outlier. I think I marked most outliers when I saved the data.
Yeah, you marked ours. You marked ours. And then how do we know if there's an outlier on our graph?
Do you have your standard data?
Yeah, it's in.
We don't know if it's right.
Can you see us?
Yeah, what is happening? We don't know where we are, so.
Oh, don't mind my labels. It says, "What are you doing?"
Can you see it?
Yeah, I can see that. And those are your corrected. What are you doing?
Yeah.
That's corrected absorbances.
We haven't really looked that hard at
No,
it.
this is right because we have all those in, and this, like, when I click on it, it goes to corrected, or maybe it goes to uncorrected.
Is there an outlier in your mix per mil corrected values?
Yeah, you haven't deleted that B yet.
What B?
Go up. B4. We have to delete that.
B?
No, B4.
Well, do it in
Delete.
your correct values, not your raw data.
Oh, Command Z. And delete it right there. B4. Okay. Now check it out. Oh, there we go.
Yeah, there you go. That looks a lot better.
Okay,